Hello students, I am Manoj Kundare, the Assistant Professor of Electronic Science. Welcome back to our e-learning platform. In previous video, we have completed the unit first of this subject. The link of this video is available in the description box. Please check it. Now, in this video, we are going to start the unit second of the communication subject named as modulation and demodulation. Let's see introduction first. In communication system, information such as voice, video or binary data transmitted from source to the destination over some communication medium or channel. For short distance communication, wired medium, twisted pair cable, fiber optic cable is used, but for long distance communication, the wired medium is not possible. Hence, we use a wireless medium such as electromagnetic wave. In case of transmission through electromagnetic wave, modulation and demodulation process is compulsory. That means if the communication distance is short, then we can use a wired medium like a coaxial cable, twisted pair cable, fiber optic cable, etc. But the distance is very large, then we have to use a modulation and demodulation technique because our information signal has very less frequency and very less magnitude. This frequency or this magnitude is not sufficient to transfer over a long distance, hence it should be modulated. Okay, what is modulation? Let's see. First of all, let's see the need of modulation. The antenna needed for the transmitting signals should have size at least lambda by 4. Here lambda is the wavelength, the information signal of low frequency, and therefore its wavelength is high. We know that frequency and wavelength are inversely proportional to each other. Okay, if the frequency is low, then wavelength is high. That means for a low frequency signal, its wavelength is high. Okay, if we need to transmit such signal directly, the size of the antenna will be very large and impossible to build. Hence, direct transmission is not practical. Hence, to reduce the height of the antenna, modulation is necessary. That means if to send a low frequency signal, that means this low frequency signal has very large wavelength, and we have to construct an antenna of the height lambda by 4. That means if the wavelength is 1000 kilometer, then 1000 divided by 4, that means 250 kilometer height of the antenna is needed, which is practically impossible. Hence, we need a modulation technique. The second need is if we transmit the information signal directly, the signal from the different transmitter will get mixed up and the information will be lost. Hence, to avoid the mixing of the signals, modulation is necessary. That means if we directly transmit a signal, then it is the possibility that other signals get mixed with this signal and the original information is lost. Okay, the third is the change the wide band signal into the narrow band signal. Modulation process is necessary. The fourth is the low frequency signal get attenuated at short distance, where the high frequency electromagnetic waves do not get attenuated very fast in space and are able to travel over a long distance. Thus, if low frequency is used for the same distance received, the signal strength will be less, resulting into poor reception. That means if we want to transmit a low frequency signal on a long distance and we consider that the antenna height is not our problem, then one another problem is persists that at the long distance the original signal lost the information and the reception is becomes very poor. Okay, that means to reduce the height of the antenna, to avoid the mixing of signals, to increase the range of communication, to improve the quality of the reception, and multiplexing and demultiplexing is possible. For all above mentioned reasons, modulation and demodulation process is necessary. Okay, I hope you all understand the things. Let's see the modulation. The modulation signals are transmitted by the transmitter via air or wire medium. These signals then reach at the receivers over the communication medium. To separate the original signal or the modulating signal from the carrier wave, the demodulation or the detection is necessary. That means in modulation process, the original signal or the information signal is placed over a high frequency signal known as carrier. This carrier is transmitted towards the receiver. At the receiver, we want our original signal back, hence we have to perform detection or the demodulation process on it. Hence, the demodulation becomes very important part of the communication system. Okay. Now, let's see what is meant by modulation. The definition says that a process in which some characteristics of high frequency wave or high frequency wave means carrier wave such as amplitude, frequency and phase is altered in accordance with the instantaneous value of the information signal or modulating signal is called as modulation. That means in modulation process the some parameters of the carrier wave such as amplitude, frequency, phase is altered with the modulating signal or the original signal. The process is known as modulation process. It is the process of the transmission of low frequency signal using high frequency signal. That means in modulation process, modulating signal is transferred with the help of the carrier signal. Okay. Let the carrier voltage be represented by the expression EC is equal to EC in bracket cos omega c t plus theta, where EC is the peak amplitude of the wave, omega is the angular frequency, and theta is the initial phase. That means this is the voltage of the carrier wave in which EC, this is the peak amplitude, omega is the frequency, and theta is the phase. Okay, if the amplitude of the carrier, that means if EC of the carrier is altered with the modulating signal remaining frequency and phase constant, then the modulation is called as the amplitude modulation. Okay. Similarly, there are three cases may arise since there are three parameters of the carrier wave. Any one of the parameter can vary, keeping other two constant. Let's see once again. When the amplitude EC is varied in accordance with the modulating wave, keeping omega and theta constant, that means keeping frequency and phase constant, the process is called as amplitude modulation. When the omega c is varied, that means when the frequency is varied in accordance with the modulating wave, keeping EC and theta, that means keeping amplitude and phase constant, the process is known as frequency modulation. And when the theta means phase is varied in accordance with the modulating wave, while omega c and EC, that means frequency and amplitude constant, the process is known as phase modulation. I hope you all understand the three types here. Let's see once again. If the amplitude of the carrier wave is changes in accordance with the modulating signal, keeping frequency and phase constant, then it is called as the amplitude modulation, and this is shown here. Okay. In amplitude modulation, we seen that the amplitude is changed. That means here the amplitude is different, but the frequency and the phase is same. This type of modulation is called as amplitude modulation. Here is the frequency modulation. The frequency modulation means the frequency of the carrier signal is changes in accordance with the modulating signal, where amplitude and the phase is constant. That means the amplitude now is constant. Okay, this amplitude now is constant, phase is constant, but only difference is that the frequency is different. That means here is different frequency, this is different frequency, this is at different frequency. This is known as frequency modulation. Similarly, we can see the phase modulation signal. I hope you all understand the three types of modulation techniques. Let's see the types of modulation. Mainly, there are two types of modulation: continuous wave modulation and pulse modulation. The continuous wave modulation further divided into two types: amplitude modulation and angle modulation. Angle modulation also has two types: frequency modulation and phase modulation. The pulse modulation has two types: digital modulation and analog modulation. Digital modulation have several types such as pulse code modulation and delta modulation. Analog modulation has three types: pulse amplitude modulation, pulse width modulation, and pulse phase modulation. Further, the digital modulation and analog modulation have different types. We see these types in our next video or in next lecture. Thank you.